In today's fast-paced enterprise world, time is everything. But in SAP projects, the software development lifecycle can be a complex business scenario full of custom objects. From creating BRD to FDS and FDS to TDS, to building BTPI flows, plus automating test script creation and execution, the process can take over 20 days. These delays not only increase costs, but also hold back innovation. Introducing Cerebro SASA, your AI-powered SAP Copilot that redefines the SAP SDLC. With Cerebro SASA, you can auto-generate FDS and TDS, create iFlows and test cases in minutes, and produce ABAP code in one platform. Faster development with our powerful AI engine accelerating development by up to 25%, enabling faster delivery, reduced costs, and smarter innovation. Cerebro SASA, empowering enterprises to deliver faster, smarter, and better with AI. To begin, let's walk through one of the key functionalities, FDS creation. In the Cerebro SASA platform, select the persona type as functional and proceed. Choose the project you're working on. Once inside the project, click on Create New Object. Provide the required details, object name, product version, RISF type, JIRA ID, complexity level as medium, and then click on Create New FDS. Upload the high-level file. Select a SASA predefined template or integrate your own template according to client requirements. Then click Generate. Cerebro SASA will now use AI to take your requirements and automatically map them into the template structure. The system generates the FDS along with sections such as purpose, scope, definitions, and references. The AI-generated predictions are highlighted in blue lines at the bottom, as this is available in editable format, so user can review, refine, or add additional points if needed. To make this process even more powerful, you'll see the SASA AI chatbot integrated right inside. At any point, you can ask questions related to the FDS, and the chatbot will provide instant answers, guiding you through the process. Finally, click on Save, and then download. A Word file of the FDS will be generated and saved directly to your local system. And that's how easily you can create and generate a complete FDS using Cerebro SASA. Next, let's explore how a technical design specification can be generated effortlessly from functional design specification. In the Cerebro SASA platform, select the persona type as technical and proceed. Select the project you are working on, then click on Create New Object. Provide the details like object name, SAP product version, RISF type, JIRA ID, complexity level as medium, and click on Create New TDS. Upload the functional specification file you already have. Since this is a new development, select New Flow. Choose the predefined template. Here we'll use the SASA standard template, but you can also upload your own structure if required. Then click on Generate. Once processed, you can see the summary of the uploaded FDS file, the generated UML diagram, the data source and access details, where it automatically captures tables and CDS views from the FDS. You can also define the sequence of data sources. The system also displays the application logic, business rules, validations, and report parameters. For example, you can define whether the program runs online or as a background job. Click on Next. Here, all section mappings from the uploaded FDS appear. You can add new sections or instructions as needed, then click Save. Finally, click on Generate. Under the Review Final Scope, the system generates the complete TDS, covering purpose, references, interface attributes, scope, design details, and more. Once generated, click on Download to export the TDS in Word format. The document can then be saved locally for further use. Next, we explore iFlow generation. Let's take a quick look at how it works. In the Cerebro SASA platform, select the persona type as technical and proceed. Choose the project you want to work on, then click on Create New Object. Provide the object name, select SAP product version as BTP, set the complexity as medium, enter the JIRA ID, and then click on Create iFlow. Upload the FDS or TDS document and click Generate. User is navigated to section mapping, where sections and instructions can be added, and interface details, security, technical descriptions, data processing logic, and reprocessing can be accessed. Next, user navigates to gap analysis to view the iFlow, overall purpose, UML diagram, data flow details, and external interactions. In the development section, select the execution type. Choose a template as predefined. Set trigger as manual HTTP. Under source system configuration, select third party. Choose HTTPS adapter, provide the endpoint, and upload the source schema. For the target system, select S/4HANA. Set adapter to OData. Enter the URL and resource path. Upload the predefined target response. Provide retry mechanism intervals. In mapping, set input validation to yes. Select the mapping style, upload the file, and validate. Upload the value mapping template. Enable response handling. Then upload the source system payload and response mapping specification files. Configure error handling as yes. Define the logging level and handle other optional cases. Then click Next. User navigates to the technical design review page, where all gap analysis, section mapping, and uploaded documents are processed to create the TDS. Here, users can view or edit interface type, attributes, configs, descriptions, process flow, and overview. Then click Next. User navigates to iFlow Blueprint, where LLM generates the blueprint from the technical document and executes it based on the selected template. Once generated, user proceeds to iFlow generation to view the real-time iFlow design. Then click Next to move to business logic generation. Users can access the generated Groovy scripts, message mappings, value mappings, and OpenAPI specification files. In Groovy scripts, all generated files are available for review. By clicking on the message mapping dashboard, all connected mapping paths are displayed with their source path, target path, and mapping rules. Selecting action opens the message mapping details. In value mapping, mappings created from uploaded documents can be viewed. By clicking action, details like country codes and names are displayed. The OpenAPI specification lets users test iFlows and review error handling responses. By clicking on Download File, user is able to download the iFlow file, value mapping file, and OpenAPI specification on your externalized parameters. Click on Upload. Select the package ID where you have deployed your iFlow and save. Then click on Artifacts, and you can see that value mapping in the iFlow is generated successfully. By clicking on the iFlow, user can open and review the generated flow in detail. Moving forward, let's take a look at the functionality, test case creation. In the Cerebro SASA platform, select the persona type as tester and proceed. Then, choose the project you are working on. Click on Create New Object and provide the required details, suite name, environment as development, Jira ID, API category, SAP product version, implementation type, new development. Upload the file you are working with. Once uploaded, click on Create Test Case Suite. SASA will then generate all the test cases for you. On the left-hand side, you can see the list of generated test cases. Details like CPI endpoint, headers, parameters, body, and validations are accessed. Under each test case, multiple test scenarios are available. For example, API response time testing, status code verification. For each test case, you can view the expected result, the test result, and whether the outcomes match. Test cases can be executed individually or all at once, with results showing as successful, failed, or paused. By clicking Download Report, you can generate and download detailed reports in Excel format. SASA's integrated AI chatbot is available at any step, enabling you to ask questions. For each test case, users can check results in the same way. By clicking on the test report, you can see the overall report and the test report for each of the scenario we have done. Click on Download Report, and a report is generated in Excel file. Finally, let's explore ABAP code generation with Cerebro SASA. In the Cerebro SASA platform, select the persona type as technical and proceed. Select the project you are working on, then click on Create New Object. Provide the object name, SAP product version, and then upload the TDS file for which you want to generate code. Once uploaded, click on Generate. Cerebro SASA will automatically generate the ABAP code, including data definitions, selection screen, and start of selection. Along with the code, 3 versions are created. Version 2 is recommended, so you can go directly to view that code. You can access the detailed design document, and the SASA chatbot is available for any questions. You can select some part of the code and click on Regenerate this part, and then save. Once the entire section has fully loaded, the Regenerate button becomes enabled, allowing the regeneration to proceed. Select the version as selected code and click on Regenerate. The selected part will get regenerated here. If the version doesn't meet expectations, the user can regenerate the entire code by selecting the version and choosing Regenerate. Once satisfied with the data definitions, move on to the selection screen, where again the system provides multiple versions. Version 1 is recommended here. Here also, if you are not satisfied with the version, you can regenerate and then click on Next. Similarly, for start of selection, the recommended version can be selected or regenerated if required. To copy the entire ABAP code, authenticate and then click Copy. Fields can be customized to dark mode, and the SASA chatbot is available to help optimize, regenerate, review for improvements, or answer related queries. Click Next to view the complete generated code, including data definitions, selection screen, start of selection, and all events together. The system highlights errors, and AI code review in Cerebro SASA begins automatically to optimize the code. Once the review is complete, the system validates the version, shown as 10 out of 10 accuracy. You can view methods, classes, if-else conditions, and more across versions. If needed, regenerate any section again. After this, the bug fixer comes into play. It automatically resolves syntax errors and updates the code versions. You can then compare the initial code with the optimized code, clearly seeing the differences and fixes applied. You can generate the TUT by clicking on Generate TUT. Now we can see about 15 test cases were generated automatically related to the ABAP code, each with a test ID, scenario, steps, expected results, and actual results. You can even add a new test case by providing instructions and saving it. Click on Download to download the test cases. Start the perfect AI project with Cerebro Generative AI Platform. Get started now.